In this short video, we will analyze the effects of a price ceiling. Let's suppose that the demand and supply curves in the market for sugarcane are given by quantity demanded equals 16 minus 0.5p, and quantity supplied is p minus 8. In the story, Q is bushels of sugarcane in thousands, and p is the price per bushel in dollars. In the absence of any government intervention, the equilibrium in this market is 8,000 bushels of sugarcane and a price of $16 per bushel. Now let's suppose that the government institutes a price ceiling of $14. Our goal is to determine the maximum possible consumer surplus as well as the minimum possible consumer surplus when this policy is in place. Keep in mind what a price ceiling is. This is a legal maximum. We cannot go above the price ceiling, so this price ceiling is going to bind since the equilibrium is 16 and that's no longer legal. What do we need to know to answer this question? We need the demand curve, the supply curve, as well as the size of the price ceiling. Let's solve this question. So here's what we know. We know the demand, the supply, the equilibrium quantity, and the equilibrium price, as well as this price ceiling amount, which is $14. We are trying to find the maximum and minimum possible consumer surplus. The first thing that we need to do is we need to figure out how many units are supplied and demanded at this artificially low price. Price is low, so we would expect that demand will be greater than supply. We're going to see that that's true as we do the math. So let's start with supply. The quantity supplied is equal to P of 14 minus 8, which is equal to 6. And if it helps you, you can remind yourself that this is in thousands. The quantity demanded at this artificially low price is 16 minus 0.5 times 14. 16 minus 7 is 9. And again, this is in thousands. Let's start first by talking about the maximum possible consumer surplus. This is going to occur when the 6,000 units supplied are purchased by the buyers with the highest willingness to pay. So those along the highest part of the demand curve. Who are these buyers along the highest part of the demand curve? Well, those are the buyers along the demand curve from 0 to 6. Why from 0 to 6? Because demand curves are downward sloping. So the first 6,000 units come from those with the highest, the tallest demand curve, so to speak. Before we do any math, it's really useful to understand what this maximum possible consumer surplus looks like. So here we have a nice graph. Our supply curve is upward sloping. It intersects the p-axis at 8. That's the choke brace. Our demand curve is downward sloping and it intersects the p-axis at 32 and the q-axis at 16. Again, a price of 32 is the choke price. How do you confirm this? You can look at the demand curve and notice that if price is 32, quantity demanded goes to 0. Sketching this with some accurate details like that is very important if we want to compute the area of this purple trapezoid. Right? We need to know how tall the demand curve is. In addition, let's talk about some more details. So I've put in my price ceiling line at $14. I've observed, we did the math, right, that the quantity supplied at a price of 14 was 6 and the quantity demanded was 9. And we've identified that the maximum possible consumer surplus is when these 6 units go to those with the highest demand curve, so the 6,000 buyers with the sort of tallest demand, as opposed to buyers who are, say, down here on a much lower part of the demand. Okay. So we want to compute the area of this purple trapezoid. In order to compute this area, we need to find the willingness to pay of the buyer of the 6,000th bushel. What I'm talking about is the fact that we need to find this point right here in order to compute the area of the triangle and rectangle that form the trapezoid shape of this maximum possible consumer surplus. Now, I have already drawn this to scale using a graphing application, so we know this value is going to be 20, but if you had sketched this, you wouldn't know that, and so you would have to figure this out. So what I'm going to do is I'm sort of conceptualizing what's going on at this point. This is the point along the demand where quantity is 6. So conceptually, if we think of the demand as measuring out the willingness to pay of each buyer, we are really looking for the willingness to pay of the buyer of the 6,000th bushel. Mathematically, what do? We're going to set 6, our quantity, that's 6,000th bushel, equal to the demand curve of 16 minus 0.5p. So we're searching for the price of the willingness to pay of the person who buys this 6,000th unit. So we're going to solve for p. We end up with 0.5p is equal to 10. Multiplying both sides by 2, we get that p is equal to 20, just like our picture shows us. Now we are ready to compute that maximum possible consumer surplus as the area of the purple trapezoid. I just want to make sure that we all understand why this is the maximum possible consumer surplus. Consumer surplus is always the area below demand and above price from 0 to Q. But here, because there are more units demanded than there are supplied, we have to think about which buyers actually get these 6,000 units. Is it the best possible case or the worst possible case? In the best possible case, these 6,000 units go to those on the high portion of the demand curve. Okay, so we have to compute this area. Consumer surplus is equal to 1/2 32 minus 20 times 6,000. That's the upper triangle, plus the area of the rectangle, 20 minus 14 times 6,000. So we see that that 20 number that we computed on the previous slide is very important to computing the area of the trapezoid. So we can do some simplification. 1/2 times 8 times 6,000 plus 8 times 6,000. Sorry, 6 times 6,000. I got it right eventually. 6 times 6,000. If we plug this into a calculator, or we can do the math out by hand, let's see, we got 4 times 6,000 plus 6 times 6,000. Well, that's 10 times 6,000, which is 60,000. So the consumer surplus is equal to $60,000 in the best case scenario. Now we want to talk about the minimum possible consumer surplus. This is going to occur when those 6,000 units that are supplied, there we go, you can actually see this, 6,000 units that are supplied don't get purchased by those on the upper portion of the demand curve. Instead, we're going to like slide down and they're going to have those 6,000 units purchased by buyers with the lowest willingness to pay that still exceeds $14. Where are these buyers, or who are these buyers? These are the buyers along the demand curve from 3 to 9. How did I figure this out? I know there are 9 units demanded at this artificially low price, and the buyer of the 9th unit, or the demander of the 9th unit, or 9,000th unit, is the one with the lowest possible willingness to pay. So to find the sort of six buyers, or 6,000 buyers with the lowest willingness to pay, I just take 9 and I move over to the left by 6. 9 minus 6 is 3, and that's where I'm getting this range from 3 equals 9. It's nice to understand what this looks like graphically. Graphically, this minimum possible consumer surplus is the area below demand but above the price ceiling, not from 0 to 6, but from 3 to 9, where we are making sure that 6,000 units are being purchased, but they're being purchased like by the wrong buyers, the buyers on the lowest part of the demand curve. Instead of the first 6,000 buyers, we're looking at the 6,000 buyers from here to here. To compute the area of this triangle, we need to do a little bit of work. We have to find the willingness to pay of the buyer of the 3,000th bushel. In particular, I'm talking about this point right here. So we know that the base of our triangle is going to be 6,000, but we need to figure out what the height of the triangle is going to be. And the height of the triangle hinges on this point, which is the value that the 3,000th buyer places on this product. So to find this point, the willingness to pay of this buyer, we need to take our demand curve and set it equal to 3. So we're going to set it equal to 3. So taking my demand and setting it equal to 3, I get 3 is equal to 16 minus 0.5p. If I start solving for p, I get 0.5p is equal to 16 minus 3, which is 13. Multiplying both sides of this equation by 2, I get that p is equal to $26. So that 3,000th buyer places a value of $26 on this bushel of sugarcane. Now that we have this missing value, we can compute the minimum possible consumer surplus as the area of this purple triangle. The math is fairly straightforward. Consumer surplus is 1/2 26 minus 14. So notice the significance of that 26 value that we found before. It's the height of the triangle, times the base of the triangle, which has to be, excuse me, has to be the number of units bought and sold at this artificially low price. So we get that the consumer surplus is 1/2 times 12 times 6,000. That's 6 times 6,000, which is 36,000. Just as a reminder, the maximum possible consumer surplus was 60,000 and the minimum possible is 36,000, and the difference comes from who buys the good. We have the right buyers, the buyers on the high part of the demand curve purchasing the good. Consumer surplus is much larger than if we slide that consumer surplus down to the worst possible scenario.